In this video, I'll replicate our paper with Fabian Mandel on control variables, and I'll be particularly replicating this figure 4 from the paper, and the figure 4 shows our simulation results for simulation number 1. And I'll replicate this with the Cline coding assistant using Kimi K2 model released in November 2025 and the positron R editor. So this is the editor, and it looks a bit like RStudio in the sense that you have these panels on the right. So there's a variables, your environment, then there's the plots, you have console here, and this is the file area. And this is the second generation product from the company that's behind RStudio. So this is their next generation, and it's built on top of Visual Studio Code, which means that it's based on a programmer's editor, and it has lots of advanced features and lots of plugins that are not available for RStudio. And we're going to be using the Cline plugin that I have here, and this is a coding assistant. I have here a folder open, so everything in Positron is done in folders, and the folder just contains one file, which is the PDF. And I ask the Kimi K2 model to study the paper and then plan a replication study, and then we will have it code a replication in R. This is a text-only model, so the model actually can't see the figure, in contrast to, for example, Claude or Gemini, which are also possible it's also possible to use those models with Cline. And that means that we have to describe what the figure looks like. This is also a challenging study to replicate for that model, because we have this figure 3 that contains some important information about the model that we used in the simulation that was not available in the actual paper. And I have the prompt here already, and then I'll just tell it some basic details about the figure, and then we have it create a plan. The planning phase is very important when you use these coding tools for any work, because you first have to kind of define what the problem is. If I could tell it just to code, but it might miss some of the details from the paper. And for example, how these other control variables are related to the y, the model might not be able to read it, and then it just guesses some values. And it's much easier to have a plan that you can review and read and comment than to try to figure out problems in logic in the code. So we first have to prepare the plan. And it's writing the plan sample size 250, that is correct. Effect of x and y 1, all x parameters are okay, that is correct. Control variables c1 are correct y, important control, and corresponding x and z varies from 0 to 0.8 in increments of 0.1. Okay, it didn't get all the conditions, and let's say there are other conditions. So let's see if we can figure out what the number of controls means. Yeah, so that's the correct values. And then we need to discuss how it plans to implement the study. And let's ask it to verify that, because this is not how we did it. We dropped based on statistical significance. So yeah, so we are testing based on statistically significant, and then we need to discuss this a bit more. Is this about correlation or regression? Yeah, so that's correct. So the model probably would have done that incorrectly, so that it would have checked for statistically significant regression results. So we need to be very specific as on what is being tested. And then let's ask it how the correlations are set. all controls are uncorrelated with y. Well, this is not true. Only the first control is, and the model, of course, can't see this figure, which shows that these controls actually have an effect. So we can ask it why it thinks that all controls are important. But let's first talk about the correlation between x and c. So core cy, I wasn't asking about that. I was asking about correlations of x and c. So let's focus on that first. I will tell the model how to set it because it can't figure it out, because it's included in the figure that it can't see. All controls have the same correlation with x. Yeah, so it says that this is a standard assumption, and that makes sense, but we say that all correlations are xc. So we can say that the paper says in figure 3 that all correlations involving x and c's are the same. So the model proposes is reasonable, but that's not what we did. Okay, so this is correct. And then we need to figure out the vector regression coefficients and how are the regression weights of x, c1 and other c set. Okay, so this is the population model beta 1 equals x, and all c's are uncorrelated with y. Only the first c is important. And then what are the coefficients? Of C2 and C3 TC. It's set in the figure, but here, but it doesn't. The model can't see it. Article doesn't explicitly say it, and well, we can tell it that this is stated in the figure 3 that you can't see, because this is a text-only model. Beta x beta x is used for all c's except c1. And then the important control, it's minus c, and we need to ask so this is not exactly correct, because this is only for a single control case, and then we need to ask what happens when there are more controls. Right, we could either give the model the correct answer because it's here, so this shows it's in figure 3, but it can probably figure it out. So let's explain the idea, and let's give it a hint. Think about suppression. What is the spurious covariance caused by all other controls by x and all other controls combined? So this should give the model a hint that all these correlations add more spurious covariance. What was again the coefficient for C1? But the idea was that the direct effect and the spurious effect cancel out. Does that happen if we use these equations? Now the model probably figures out that it's not correct. Yeah, so that's the correct equation that we have. So it's k times rho, and that's the equation. And let's have it print out the final plan for our review. And then we need to have one more detail. I want 1000 replications and 100 when testing. Or let's just say that I want 100 replications, will increase it 1000 when developing code, just to make it run faster. Also use future replicate for running the replications with maximum number of cores. So we want to run parallel processing just to make this a bit faster, and future replicate is a very good and easy to use function for doing that. And final review, and then we will implement. And then let it go. This is a very strong coding model. So given that we discussed the plan already, I expect it to basically do this in one go and just produce the working code. And we can see here that there's still plenty of context remaining. So at some point when we start to reach the full context length, which is 131,000 tokens, we need to compact the discussion. So that means that we're gonna write a summary, and then the model will continue from that summary instead of because it can't go on with the current context. So it has to kind of like start from fresh because its memory is full. And all right, it wants to install these. I have this installed, but let's have it do it. Now it's writing the code, and this code editor, it's a diff, so that means that it shows a difference between two files. And we originally don't have any R file, so it's an empty file, and it looks a bit weird, or because it's just this is like the old file which doesn't contain anything, and the red lines, the green lines are something that is adding, and if it was deleting, then it was written in red. All right, so let's review the code, and probably wants to run it. So this looks correct, and then we have a maximum number of cores here. That looks correct. Then this is correlation matrix. That's correct, and then we generate data. And X and controls okay. You could just keep them in the matrix. okay, it ran into an error, and now it'll fix it. So how these agents work is that they write code, they run it, and they might run it piece by piece, and then when they see an error, they go and fix it, and then they run it again. So compared to using ChatGPT or some other chatbot to help you code, where you have to put your code in there, like you ask for code, and then you have the error message that you put there, and you ask the ChatGPT how to fix it, and you have to fix it yourself. This is something that automates the process, and I could let this run here alone for a while, but it probably finishes fairly quickly. This here is the cost of the API calls. So this Kimi model is fairly inexpensive compared to many other state-of-the-art models. So the cost of this model is like 1/5 of the cost of Claude 4.5 Sonnet, or Claude Sonnet 4.5. And here we can see the total cost. So we have spent 66 cents this far in this session in computational costs. And each of these calls, it tells how much the call is costing. And if it sends over files, like earlier we sent over the full PDF, that was probably a bit more costly. But other than that, these are like a couple of cents. So this is not that expensive to run. But if you run, for example, Claude, which is 5 times more expensive, then we would already be at 3.5 euros at this point. And you can see that if you use this on a daily basis, then the costs can add up with this kind of API-based pricing. But if you only use this infrequently, then paying per token is probably a good idea, compared to, for example, paying 25 euros for Gemini, or $25, I think it's Gemini Pro, or $25 for Claude. That's a ballpark price. I don't remember the exact pricing of these models. So we can see here that it is trying to run something, and it runs, and it uses the terminal and runs R there, and we can see what it's doing here. And one thing about this code that I don't like is that it's a reasonable thing for the model to do, but this is not what I would do. So I asked it to use future replicate to run the replications, and this parallelizes the replications, but it uses future maply here, and this is like the parallelization on the simulation condition level, and I don't like that approach, because this is like nested parallelization. You have one set of parallel computation and then another one. For this kind of problem, running the actual replications in parallel and then just have like a for loop or something that goes over the simulation conditions would be easier to implement, and it would also be, I think, a bit more computationally efficient, because it's easier to split 1,000 replications over cores than it to split we have like 63 conditions that don't run at the same amount of time, because when you have more controls, then the simulation runs slower. It's also difficult to troubleshoot, and because when you run in multi-core setup, then that means that some of the error messages don't come through, and it's difficult to pinpoint where they happen. So we could tell the model that just to use single core when looping over the simulation design. So let's go back, and because now it got stuck, and I don't know, maybe I typed something and then it got stuck here, and so we're gonna go, okay, now it recovered. Another thing that I don't like about these models sometimes is that when they do some changes, they create a new copy of the file, and it makes sense if you have like a big change, like you go from this implementation to using, for example, the sim design package for simulations, but just like changing from multi-core processing in one loop to single core processing is not a major change. So I don't think that it should create a new file. But let's just the model do what it does. This is a bit slower than, for example, Claude Code, and I think the reason might be that this agent does a lot more, like rewriting the entire file compared to Claude Code, which can use like editing, just write like what has changed since the last version. So this is much easier to troubleshoot because it's just nested loops, and it's probably adding drop equals false somewhere. It's difficult to see what it did. So this is one of the problems with auto approve, is that sometimes it flashes you to change, and then you don't see what the actual change is. So this is and now it's again writing it all over again, and it takes some time. And we can see that there's now 4 different versions of this file, and I wonder what it's gonna call the next one. Is it like final corrected really or something like that? This is a super weird solution that the model is doing. So it somehow couldn't get the regression command to run, and then it works around by just doing the matrix calculation that regression actually does internally. Yeah, so we hit the token limit here, and what we can do now is just to run it ourselves and see what it does. The number of conditions is, so it runs frugal and prolific in 2 different, and that's the reason why it doesn't why there's so many conditions. And let's see where the problem is. And the problem here is it's in the future apply, so it's very hard to find it. And so one of the problems with these models is that when they run into an error, they don't know how to troubleshoot the error, so a human would be able to run this code little by little. Claude code can do that to some extent, but this model is apparently not able to do it. And you just run it, and then you try something, it doesn't work, you run it. So they just don't have this this good troubleshooting skills that human would have. So this is let's see where it tries to do that. So let's see, and generate Y. So this would be the first C, and if there is just one correlation, then this is the we should have drop. We should have here drop equals false. So this is something that often happens when you have just one, like there's one correlation, then this produces a vector instead of a matrix, and yeah, so that's a problem. So we fix that by hand because I want to wrap up this demo, and the model probably could figure it out eventually, but we would have to compact probably quite many times. So let's run it and see what it looks like. Another thing that I don't like about this is that it runs the frugal and prolific perspectives on different data. So what we did in the paper is that we used the same sample, and then we estimated the frugal perspective and the prolific perspective using the same sample, and then we could compare. And so now it's running. I assume it runs. So that's the development. That looks pretty good actually. So the model can't see what the figure looks like. So that's so it doesn't know that the legend actually goes to the right. If I was using a multimodal model, they would probably be able, or I've done this with Claude Code and Gemini CLI, and those are able to look at the figure in the paper and see that this legend actually goes to the right. And now it runs the final production sample with 1000. But this looks pretty good. Okay, let's take a look at the final figure when it's done. So I would just collapse the data and calculate points and plot lines. That's what we did in the paper based on the points, instead of feeding a model to the data. And this also kind of artificial that there's curvature, because there really is none. It just goes through these specific points. So it is running now the simulation corrected, and it's running this here. So this is a bit awkward here, because when I say that use 100 for development, then I would assume that the model understands that while we're testing the code, we should run 100, and it actually run 1000 replications, and that's the reason why it's taking so long. So I should have told it to run 1000, but we'll wait, and ultimately it's going to be done. It doesn't actually take much longer to run 1000 replications compared to 100. Okay, so let's see the final. Yeah, it replicates our paper. So this Kimi K2 model is pretty good at coding, and this is the first time I use this model. So I don't know if the glitching to not identify that it needs to add a drop equals false as an option to the matrix subsetting. I don't know if that's like a single thing, or whether that is indication of reliability of this model. Generally, you would probably never use this kind of models for replicating papers and have them read the figures. You would probably just explain what the design is that you want to have, and then instead of let the model try to figure it out. And once the model had the simulation design, it pretty much nailed the simulation on first go. It just produced a fairly complex solution, and then I had to adjust it a bit. But this is definitely, if we consider that it costs like $1.20 for this session, for anyone who sporadically wants to do simulation work in R, using this tool would be a good pick in my opinion.